Okay, as we've seen before, b to the x equals c is equivalent to the x equal log to the base b of c. Also, log base b of x equals log of x over log of b. So the base of the log here is the log, the quantity of which you take the log in the denominator. Okay, now log to the base 7 of 4x minus 3 equals 2. This is an equation. We're trying to find a value of x that makes this so. How do we solve this for x? Well, we change its form to exponential form. But first, we want to be very careful to put this in a form that exactly mimics this expression, the x equals log base b of c. Okay, so that means that the log base b is going to be on the right and some number is going to be on the left, or some quantity or some expression. So I'm just going to switch the sides of this so that this now exactly matches this form. This is the same as the form then that we have here, which I wrote down here again, x equals log base b of c, with what? Well, x has been replaced by 2, right? B has been replaced by 7, and c has been replaced by 4x minus 3. Okay, it's very clear then. X has been replaced by 2, b has been replaced by 7, c has been replaced by 4x minus 3. Now, if you're not very careful with that, since there's an x in the rule here, and there happens to be an x in the equation, you've got to be very careful about what's being replaced by what, because this x has nothing to do with this x, or this x. Okay? This x has been replaced by 2. This x is part of the expression that replaces c. And of course b is 7, and that's very clear. Well, now the equivalent form of this equation then is b to the x equals c, where b is 7, x is 2, and c is 4x minus 3. So we replace x by 2, b by 7, c by 4x minus 3 in this expression, and we get what? B is 7, so that's 7 raised to the x. Well, x is, we replace x by 2, so we get 7 to the second power equals c, and c needs to be replaced by 4x minus 3. Now we have an equation that we can easily solve. Okay? Now I don't think I wrote out the solution, but yeah, very quickly. Take a different color of chalk. Okay, so this equation, 7 squared is 49, so we get 49 equals 4x minus 3. Well, we add 3 to both sides. And we get 52 equals 4x. Then we divide both sides by 4. And that's 13. And I think just about everybody in class said, okay, that's good. They went ahead and solved it, and they got 13. Okay? So I don't think anybody had any trouble solving this, but there's a solution. And of course, I didn't go through all the steps, but you need to. I've beat you over the head with the steps and the meanings of the steps to the point where it would be redundant to keep doing it. And it would just take up your time. You try to get through this video, you don't need to see me repeating what you should already know by now. Okay, well, now let's take the equation 5 to the 3x minus 7 equals 9. Okay, which of these forms? In first place, is it in one of these forms? Because if it isn't, then likely none of this is going to help us. Okay, if it's not in one of these forms or can't be put into one of these forms, then we can't use this technique to solve the equation. Okay, well, but we recognize this is of the form something raised to a power equals something else. And we write that as b to the x equals 9. So we need to replace b by 5. We need to replace, and that's b to the x equals 9, it's b to the x equals c. The form doesn't have a 9 in it, does it? Okay, we replace c by 9, and we replace x by 3x minus 7. Well, we go to the equivalent form, x equals log base b of c, replace x by 3x minus 7, replace c by 9, and replace b by 5. There's our equation. Log base 5 of 9 is something that can easily be calculated. It's a unique number, okay? You can calculate it to great precision on your calculator, so that we just regard that as a number. That part is sort of done, not completely. And then we get the 3x minus 7 on this side. We're trying to solve for x. Okay, so what do we have to do? Well, we add 7 to both sides, and that's going to give us this. And then we divide both sides by 3. Being careful to write out this whole thing as the numerator and 3 as the denominator. Then we apply this rule. It tells us log base b of x is log x over log b, so that log base 5 of 9 is log of 9 over log of 5. Okay? Now, at this point, we have an exact solution. And we can approximate this solution using the calculator. Okay, now if you do this, this is actually a complex fraction, but there really isn't much point in expressing this as a simple fraction. We can simply make sure that we have parentheses around our numerator so that we don't accidentally fail to divide some of our numerator by 3. So we just put parentheses, put a left parenthesis here, and then we start doing log 9 divided by log 5 plus 7, and don't forget to close the parentheses, and then divide by the 3, and you get a numerical approximation. Now if you're asked for an exact result, it's got to look like this. And I don't really care in this case if it's simplified any further than that, because this expression is really probably the easiest one to calculate. Okay, so, well, that's a solution to this equation. There's really not much to it. You just have to know these two forms and this rule. Recognize if you have one of these forms, and if you do, apply them by carefully seeing what has to be substituted for what. Okay, well, we're going to do another one, but we'll break and do that in a minute.